So let's just see how we can convert from infix notation to postfix with the help of one stack. So the postfix or the reverse policy notation is a mathematical notation in which the operators follow their operand. So suppose we have one infix notation a plus b. Now we can convert this to postfix. So in postfix, the operators will follow the operands. That means first of all we are going to have the operand a, then we're going to have the operand b, and after this we're going to have this operator plus. The operator is placed after these operands. So that is the postfix of the infix. Now we can perform this conversion with the help of a stack. So here is the algorithm for infix to the postfix conversion. So first of all we're going to initialize one empty stack. So that means we are going to use one empty stack. So in the stack we're going to have one top pointer which will initially point to -1. And also we need one empty postfix string. So this is our infix. We need one empty postfix string. Now we're gonna scan the infix expression from left to right. So this is our infix expression. So from left to right we're gonna scan this expression. Now for each character, if we found one operand, we're gonna immediately add it to the postfix. So here you can see first of all we found this operand a. So we're gonna add this to the postfix string. And now whenever we found one operator, the operator can be plus, minus, multiplication, division, or the power. So whenever we encounter any operator, in that case we're just gonna simply pop from the stack to the postfix if the precedence of the stack top is higher than the current operator. So currently the stack is empty, so we don't have to do anything. We can simply push that operator into our stack. But suppose previously we had one multiplication operator in the stack. So in that case we have to compare their precedence. The multiplication has higher precedence than this addition. So because of this we had to add this multiplication operator in the result string. For now the stack is empty, so we're just gonna simply push this operator into our stack. So here we have to push the current operator onto the stack. Now if we found any left parenthesis, the opening parenthesis, in that case we're gonna push that parenthesis into our stack. And if we found any right parenthesis or the closing parenthesis, in that case we're gonna pop all the operators from the stack and we're gonna append this to the resultant postfix string until we found the opening parenthesis in the stack. And then we have to discard the opening parenthesis. So we're gonna pop the opening parenthesis. Now after the end of the loop, we're gonna pop all the remaining operators from the stack and we're gonna add this to the postfix resultant string. And after that we have the end of our algorithm. So here you can see we have the plus operator. So now we're getting one operand. So we're gonna put this into our resultant postfix string. So now we have the end of the loop. So now we have to pop all the remaining operators from the stack and we're gonna add this to the resultant postfix string. So that is the postfix notation for the infix a plus b. And this is how we can follow this algorithm to perform the conversion. So here is our code. So first of all we have created one stack and also we have initialized the top pointer to -1, and then we have this push function. So the push function will push one element to the top of the stack. And also we have the pop function. So this pop function will remove and return the top element. So next we have the precedence function. So this function will return the precedence of one operator. So we pass the operator as a parameter and then it will check if that is the addition or the subtraction, so which has the lowest precedence. Then we're gonna return 1. If we found the operator is multiplication or division, so then we're gonna return 2 because it has a precedence higher than the addition or subtraction. And lastly we have the power operator. So it has the highest precedence, so we're gonna return 3. So next we have this is operator function. So this function will check if the character is one operator or not. So if the character is one addition, subtraction, multiplication, division or the power, in that case we're gonna return 1, signifying that these are all the operators. Otherwise we're gonna return 0. And lastly here we have the important infix to postfix function. So this function takes the infix expression and we're gonna get the resultant postfix expression. So first of all, we're gonna use one loop to traverse the infix expression. So first of all, we're gonna check if the character is alphanumeric or not. So here we're using the isAlphanumeric function. So if we found any operand, so in that case we're gonna add this to the postfix. So here we're gonna add this to the postfix. Otherwise, if we encounter any opening parenthesis, then we're gonna push the opening parenthesis to our stack. Otherwise, if we found any closing parenthesis, then we're gonna pop all the operators from the stack until we found this opening parenthesis that we have pushed earlier. Now here inside we're gonna run this while loop. So we're gonna run this while loop until the stack is empty or the stack top has the opening parenthesis. So in every iteration of this loop, we're gonna pop the element from the top of the stack and we're gonna add this to the resultant postfix string. So the loop will break whenever we encounter one opening parenthesis. So in that case, we're gonna remove that opening parenthesis from the stack also. So else we're gonna check if the character is operator or not. So if we found one operator in the infix expression, then we're gonna run one loop to check the precedence with the top of the stack. So if the stack is not empty, that means if we have previously operator pushed into the stack, so we're gonna compare the precedence with the top of the stack with the current operator we have. So if the top of the stack operator has higher precedence, so in that case we're gonna pop the operator from the top of the stack and we're gonna add this into our resultant postfix string. So we're gonna continue this process, and after that we're gonna push the current operator into our stack. So after the end of this for loop, so if the stack had some remaining operators, we're gonna pop all of them and we're gonna put this into our resultant postfix string. So now our resultant postfix string is ready. So all we have to do is add one null terminator at the end of the string. And now inside the main method, let's just create one infix string. So the infix string will have a plus b, and also we're gonna have postfix resultant string. So let's now call the infix to postfix function. So first of all, we're gonna pass the infix and then the postfix. Now after the conversion, let's just print the result. So here we're gonna print the postfix result. So this was the infix expression and this is the resultant postfix expression. So you can see the operator is placed after the operands. So that means our function is working properly. So this is the way, with the help of one stack, we can convert one infix to the postfix. So hope you understand the concept. See you in the next one. Take care.